All right, chapter 5.1, combining functions, okay? This is something that we've done before. So hopefully it goes really fast and you feel very comfortable about it. The reason why I say we've done it before is because this is an Algebra 2 concept of combining functions. So in Algebra 2, we've reviewed operations of functions. So how to add, subtract, multiply, divide functions. Does that sound familiar? Okay, good.
Oh wait, we don't have to take a AP test of it, do we?
No, we just take a final.
How's that?
Okay, so here it says if a driver with a reaction time of 1.5 seconds attempts to stop while traveling at X miles per hour on dry level pavement, the reaction distance is R of X equals 11/5 times X, and the braking distance is B of X equals 1/11 times X squared, where both distances are in feet. It wants us to write a formula for a function S in terms of R of X and B of X that gives the stopping distance when driving at X miles per hour. And then evaluate.
I bet you were good at it.
I was fairly decent. So what do you think we would be doing? How do you stop? In order to stop, you have to do what?
Take the break.
Okay. In order to stop, you have to react and hit the brakes, right?
Yeah.
Like you have to have that reaction and hit the brakes, right? You have to be alert enough to do so. So when we're creating a function of when to stop, it's a combination of those two things. Does that make sense? So my stopping is going to equal, so my S of X is going to equal me reacting and me braking. Does that make sense?
When is our final?
The first week of December.
For real?
No, it's the week after the first week we come back from Thanksgiving.
Ooh, that's our final? So second semester?
No, after Thanksgiving. So not the
Oh,
week,
after Thanksgiving.
not the first week we come back, but it starts that next week.
Okay.
Okay.
Oh, that's gonna be over a little early then.
Mm-hmm.
What do we do?
Stare at each other.
Oh, that's a lot.
All right, here we go. So when I'm looking at this, if I have R of X and it wants to find S of 55. So that means I'm plugging in 55 into both of these equations. Does that make sense? And then I'm going to add their results together. Okay. I didn't mean to open that. So we're plugging in 55 for both of them. So we're going to have 11/5 times 55. That's our first. That's our R of X. Agree?
You know, you can just put a fraction.
I can on mine. You can on the newer ones. I know what I'm doing. Okay. Plus, and now we're going to put in our break time. So the break is 1/11. And this time times 55 squared. So notice how we did R of X plus B of X. And when I hit enter.
Why did we do it on the second one, but
What do you mean?
like 11 divided by 5 times. Yeah, when you did it.
Oh, you did it. I put parentheses instead of.
Okay.
Yeah.
Do it.
You either got to use parentheses or the multiplication button.
Okay.
Either one.
Oh, what did you put? All right, you put it like 11/5 times 55 plus 1/11.
Times 55 squared.
Okay, that's it. Is there a way I can like copy this to the next equation?
What do you need to copy it for?
Oh, because I forgot the square.
You arrow up and hit enter.
Oh.
Okay. All right. So if I'm going 55 miles per hour, how far do I need to stop before I hit anything? Like what's the good, how far does something have to be?
You gotta be like 500 yards.
396 feet.
That is like 20 yards.
My thing is like, why did you choose that? Like, because
Yeah, completely.
I don't know.
In terms of yards,
In terms of yards,
that's divided by 36.
230 yards.
It's 11 yards.
Where? No.
what are you stopping?
There's-
for? And how
wait,
fast are you going?
I said that's inches. This is feet, right? And there's 3 feet in a yard. My bad. 132.
There you go.
Oh. I was still.
Yeah, I was like, wait, 132. Okay, so that's what it's telling you. That's how much time you need to start braking in order to start slowing down without crashing on your brakes or running into the next person. Okay, now I want us to compare the graph. So when we look at the graph, we're going to graph each part. We're going to graph the linear, the quadratic, and then the combined of the combination of the two. So we're going to graph 11 fifth x,
Now you just been like,
and we're going to graph 1/11 x squared, and then we're going to graph them combined. You're doing with x, because it's so we're graphing 11 fifth x plus 1/11 x squared. Okay, now that I have all three, I want to look and see what does it look like on a graph together. Then I'm going to hit graph. So there's my linear. There's my square. Hit graph. And then for some reason, I'm zoomed so far in. So I'm going to zoom out. Zoom is how you zoom in and out. Okay, so I can kind of see this. I can also change my windows because this is a real world problem, right? As far as real world, do I have to worry about negatives?
Yeah. No, you don't.
I don't.
You're not gonna stop at negative.
Yep, I can. How fast can we drive? What's a reasonable speed limit?
Oh, 65. 65.
I say 75.
Wait, where did you get that from?
We went to Windows. We can count by 5s. It didn't really matter.
So if the minimum is negative, what do you do?
You got 75?
In the
Where?
I hit huh?
Where'd you get 75 from?
I just asked what would be a good maximum speed for us to calculate or look at, and I said 75. Your minimum or is your distance going to be negative? No. So do we need a negative distance? No. And then max. Well, we just did one, and it was 396 feet, right?
Why is it max?
Or miles per hour. Well, feet, yeah. How? Let's say 500.
You can change it.
When you click window, you can change and count by it.
500. I knew it.
So when I hit graph, I'm now going to get a view of something more realistic. So this is just your reaction time. Here's your braking, and then them together is the one on top.
So did you just replace it?
So I went to window and I changed my values. And then when I hit graph, I now can see it in a better view. Does that make sense? Okay, so it says, explain how the graph of S can be found using the graphs of R and B. So when you're looking at S, all you're doing is taking the value at that amount, adding it together, and that's going to put you at S, right? And that's why S, as you can see, is it above both of these graphs? Yeah, because their Y values are greater. Okay, so we can compare by looking at a table. Do you guys remember how to change our table to only see certain values? Second what? Second window, and I want to change my table from auto to ask. So I'm going to go from auto to ask. And when I go look at the table, I can now put in the value. So if I put in 11, I'm going to put in 22. I'll put in 33. I'm gonna put in 44, and I'm gonna put in 55 as my speeds. So if I'm going 11 miles per hour, this is how much time I need to react. This is how much time I need to brake. If I'm going 22 miles per hour, this is how much time I need to react. This is how much time I need to brake. Do you see that? So if you add these two together, so 24.2 plus 11 is going to give me what? So look, as I scroll over to Y2, what does it say? It says 35.2. Because Y2 is the combination of me adding my reaction and my braking time. And that's the relationship between those. And you can see it more clearly on a table with specific values. And that's how you can combine functions in real world problems and situations. Questions, comments, concerns?
I get it all. This is the calculated part.
Okay, which part of the calculator? We use the calculator to see the graph.
I got confused at the window part. I didn't know what you were facing.
So we were changing our values, our domain and range of the problem to make it more realistic. Because we're not going to talk about negative speeds. We're not going to talk about negative distance. So notice how I changed them from 0. And there's a set speed limit. Are you going to be going 135 miles per hour? No. So why do I need my max to be at 135? And this just right here is like, what do you want to count by? So I'm counting by 5s because I just didn't want a whole lot of marks.
Yeah, I think I confused it probably about the Y max.
Okay, and then the Y max. When we did our first one, we got 396, right?
Yeah.
So you said 500 for some reason. We don't know why, but we got 396. And because we got 396, that tells me, okay, well, my distance can be potentially larger than 396.
That's why I say just like 500.
Yes.
Hey, that's what I did.
Why?
Is what do you want to count by? So if I look at my Y values, they're counted by 50s, all the way up to 500.
Okay. And the X rest.
You don't change that. Right here, you leave that alone. You're only worried about the first 6 changes.
This graph.
Wait,
After that.
Huh? Huh?
You can wait till the 500 for
Because I chose 500. If my X max is 75, I know that my distance is going to have to be greater than 396 to stop.
Do you see this?
Yeah.
Oh man, to get into that one you said second.
To change it to from auto to ask, you press second window and you see where it says independent. You want to switch it from auto to ask and then go look at your table. And this allows you to put in the values that you want.
Where do you think that was?
Second graph.
Okay, I got it.
Okay. All right. So this was just analyzing, reading, and notice that, yes, it's a word problem, but was it really a hard problem in the end? No, it wasn't. All right. So conclusion of this problem is that you can add functions together, even if they're not the same function. Does that make sense? I can add functions together, even if they're not from the same family of functions. So, for example, we have g plus g at -2. What that tells me is I'm going to add g to itself. So I would have x plus 2 plus x plus 2. Does that make sense? Because it says g plus g. And what does g equal? 2. X plus, I wrote 2 and it's a 3. And y'all were going to let me. I was confused too. I was like, why are they singing this with me?
I'll have to run it down.
Let's try that again. G,
Oh,
let me.
500.
G of x is x plus 3. So it says to add them together. So we have x plus 3 plus x plus 3. And what does that mean? What does that simplify to?
X plus 3.
Yeah.
Negative 3? 3? What do you mean?
What does this simplify to? Not x squared, but just 2x plus 6. It only becomes squared if you are multiplying.
I thought simplify was 1 time.
Simplify means to reduce the number of characters that you have.
Isn't that adding more?
I had 1, 2, 3, 4, 5, 6, 7 characters, and I only now have.
What can, we got the wrong thing, my bad.
Okay,
I was at the long X plus 3 up there.
And then you got something negative.
and that's what the G plus G. The -2 says that I'm gonna let X equal -2. So from here, if I let X equals -2, what do I get? That's not what that is. That gives me -4 plus 6, which is 2. So my final answer would be 2.
Wait, what? Why is it, so you're saying equal to a negative?
This is function notation. So with function notation, you're saying, here's the function operation. This is what X equals. So what was our operation that it wanted us to do? Add them together. After we added them together, what did it want us to do? Substitute X equals -2. If you saw, if this said F of 3, what would you tell me to do, Fox?
I don't know. Replace X with 3.
Replace X with 3, right?
Oh,
So that's what this is telling you. It's telling you do this operation and then replace X with -2. Does that make sense? Okay, let's try another one. So here we have F minus G, and then we're gonna let X equal 0. So it wants us to subtract 4X minus X cubed minus X plus 3.
okay. Thank you.
Are you with me? Yeah. So we have F minus G. Is this not F? Yes.
Yeah.
Is this G?
Yeah.
So we get 4X minus X cubed minus X minus 3. That 3 got real weird.
Then you would simplify.
And we would simplify. So we end up with negative X cubed plus 3X minus 3. So this part is done.
And then you put 0 and then you put that.
And then we're gonna let X equal 0. So we have -0 cubed plus 3 times 0 minus 3. And what is the answer? -3. So we did the operation and then we substituted in for X. We did the operation, we substituted in for X. Terrible, doable? Doable?
But it-
Oh. No glasses.
Yeah, that's doable. Now, you say doable, then we go to the next problem, then it's just not doable.
Why not? What is this?
That might be doable.
What is this?
So multiplication.
It's multiplication. So what are we gonna do first?
Wait, but that was the big
Minus-
We're just gonna set them up.
So 4 minus X3 times X plus 3.
There we go. So we have X plus 3 times 4X minus X cubed. Because that's what it tells me to do, to multiply G times F. Agreed?
You just feel like a factor, like you fuck up.
Mm-hmm.
It can't go backwards. Like that.
Yeah, same thing. Yeah. So I distribute and we're gonna get 4X squared minus X to the 4 plus 12X minus 3X to the 3rd. Agreed? Some good old fashioned FOIL.
Oh,
First, outside, inside, last,
what the hell? Oh.
last. Okay, now we did that. Now what do? There's no like terms. So we just gotta let X equal 1. If I let X equals 1, everything is just gonna be its. So we have 4 minus 1 plus 12 minus 3. I don't know what I'm doing. What's 4 minus 1? 3. What's 3 plus 12? I don't know why. 15, what's 15 minus 3? 12. Yay, nay? Is it terrible? Okay. All right, so we have G divided by F. So G's in the numerator. And F is in the denominator. There's nothing that I can do. I can't simplify. So I'm done. You can't simplify it. You can't reduce it. Even if I factor it, is it going to make it easier? Nope. So I did the division, and then after I do the division, what does it want me to do? Sub in a -3, because x equals -3. Everywhere there's an x, it becomes a -3. So we have -3 plus 3.
That's 0.
Oh, do I have to even go any further? No, because 0's in the numerator, which just makes it 0.
Those are my math, 0 too, right?
It will be no solution. Mhm.
What is that?
If 0's in the denominator, it's no solution.
Michelle, are these like super easy questions or are these like?
Oh, no, these are the super easy ones right now.
Yeah, that's what I was thinking.
We're
But
gonna
these,
do a
I'm
whole,
like, this, I'm looking at this and I'm like, oh, I can do this.
we're gonna do our homework. and figure
Yeah,
out-
we're gonna go to homework.
Actually, though,
All right, so what we've been doing is we've been plugging in numbers, right?
yeah.
Now, we're not gonna plug in the numbers. It just wants you to find F plus G, F minus G, FG, and F divided by G.
So addition, subtraction, multiplication. and then-
You're just not plugging in numbers,
She said that next time, because that is like.
but you see it.
Yeah.
You knew what I was talking about,
That's about right there.
okay? But isn't this what we did? The difference here is that we had a number to plug in the end. What's happening here? Do we have a number to plug in? No, we don't. So we're gonna do it, and then we're just gonna describe what is the domain, what happens,
Write it down.
okay? So here's our f of x, and here's our g of x, and we're gonna find their operations. Add, subtract, multiply, divide. Add, subtract, multiply, divide.
Let's go with it, so we all get yours.
Don't let it. All right, let's talk about the domain, because it says talk about domains. What is the domain of all quadratics? What's happening to your x values in quadratics? Do they have a starting point, a stopping point? They're all real numbers. It goes from negative infinity to positive infinity. Agree? Okay, let's talk about the domain of square root functions. Do they have a starting point or a stopping point?
One of you don't wanna answer it.
Yes, they have one of them. What do they have? They have a starting point, and where do they start at?
0.
0. Good job. The domain of this square root function in particular is that it can start at 0 and continue to infinity. Why can it start at 0?
Because why can it?
Because the square root of 0 is what?
You know,
0. That's why.
I just thought it was like common sense, right there, you know.
Mm-mm.
Since it has to have a start.
But I can't start at -1 because can you take the square root of a -1? That's why it has a starting point.
Okay, makes sense.
Okay. All right. So the first thing it wants to do is add them together and then talk about what it looks like. So if we're good,
X squared.
F plus G. What does that give us?
X squared plus 1 plus square root of X minus 1.
Okay. So we simplify that. And what do we get?
Hold on, let me do the math. X squared plus, X, X squared plus square root of X minus.
Those like cancel out, right?
Mm-hmm. These two will
Oh.
cancel out.
So,
I know.
wouldn't the X squared and the square root?
Yeah.
Cancel out too?
Mm-mm.
But they're like opposite.
Wow.
Why would they cancel out when you're adding them? There's no equal sign.
Why-
I'm not
why-
isolating anything.
Figured one would be negative.
Oh,
So then what are they adding together? Like nothing.
That's it. That's your answer. That's your function.
so X squared plus square root.
So let's go back to what we did here. Remember how we had this function and that function,
Yeah.
and we added them together? They just created a new function, right? Same thing here. When we add these two together, they're creating a new function, and that function looks like this. We have x squared plus the square root of x. Okay, our x squared, does it have any limitations on its domain? No, but does our square root? Yes, so that means that my graph should start where now? 0, because I can't go into negatives when I have a square root. So when I hit graph, notice how it starts at 0. It's no longer the whole square root.
Plus, if the square root doesn't throw me off.
Square root's gonna throw you off. So the domain here is, starts at 0 and goes to,
So would it kind of be the same, when it comes to subtracting two?
it's the same process, exactly. So now we're gonna do f minus g, which means I have x squared
The ones who just
plus
go-
1 minus the square root of x plus 1.
So it'll be the same thing going down. Right?
It is negative, yeah.
Yeah, but the 1 is also, you don't just change the square root sign, you also change its second term sign.
Well,
You're not just subtracting the square root of x, you're also subtracting the negative 1. And minus a negative makes it a positive. So it becomes x squared minus the square root of x,
why didn't we change it? in
Plus
the
2.
first problem?
because it was addition.
Okay, but the square root of x minus 1.
It was just addition. When you're subtracting something, you have to subtract everything. So it's subtracting this and that,
Okay,
which is why it became a positive.
okay, that makes sense.
Okay,
So it's x squared minus square root of x plus 2.
and again, we have a domain restriction because of our square root. What can x not be? Negative. So we still have to start at 0 and work our way to infinity.
And you know,
Huh?
Hold on, hold on.
All right, so before we start multiplying, I just want to reiterate the fact that, is there another way that I can write a square root? There is. Anyone remembers the other way to write the square root? Nobody?
Another way to write the square root,
Mhm.
does it involve a fraction?
It does involve a fraction.
Well, like number 4. Would it be an improper fraction?
Mm-mm.
Okay.
All right. The other way that this could be written is x to the 1/2 minus 1. A half power is the same thing as taking a root.
Hold on. What are we doing right now? Are we doing multiplications?
We're about to multiply.
Oh,
All right. So for it says f times g, right? So f times g means we have x squared plus 1 times x to the 1/2 minus 1.
there's no square root.
Oh, x to the half? Okay,
No, it is.
It makes it easier for you to multiply with your powers.
yeah, they're just gonna throw me off when I'm toiling.
Okay? When you are multiplying and there's a power, what are you doing to those two powers? You're adding. So what's 2 plus 1/2?
2.5.
2.5.
I've never seen that.
So it becomes x to the 5/2.
That's a thing?
Can I do like
X
X
to the 5/2?
square
I
root
know,
and
I don't like, can I be put x to 2.5?
I write it as improper. You even said improper, remember? You did,
No,
but it wasn't just the improper by itself.
Wait, are we doing the multiplying one or doing the dividing?
We're multiplying.
no.
So we have x squared times negative 1 is gonna give us negative x squared.
Oh, I see. I got it.
So we have 1 times x to the 1/2 is just gonna be
Half, x to the half, wait.
x to the 1/2.
Yeah.
And then 1 times -1 is gonna be -1. So there's my multiplication. Okay? So domain restriction. Again, 0 to infinity. And that's because I still have a square root present, right?
So all what? Anyone with a square root?
Mhm.
Okay.
Anything with a radical, it's gonna, like, if I had a cube root, it would be 1/3. If I had a 4th root, it'll be 1/4.
But it's also gonna start from 0.
Evens do. The cube roots are infinite.
Okay.
Because you can put a negative underneath a cube root. You just can't put a negative underneath a even root.
Makes sense.
All right, last little piece. We have F divided by G.
Wait, you don't simplify that? You don't do the,
There's nothing to simplify. You can't combine anything.
you can't combine the x squared, oh,
X's have to be exactly the same in order to combine. Are these exactly the same?
so then it's the same thing.
Square plus 1 over half minus 1.
So we have x squared plus 1 over x to the half minus 1. And you can't simplify that. So guess what?
That's your answer. Oh,
That's it. So what can the denominator not be? 0, right? Your denominator cannot equal 0. What would x have to be in order for this to equal 0?
um, 0?
1.
1?
Oh, 1, yeah.
The square root of 1 is what? 1. 1 minus 1 makes what? 0. So your domain is all real numbers, but x cannot equal not 0, 1, guys. Your denominator can't equal 0, but your function itself.
Are we gonna put that into like?
So in Pearson, I think it's gonna want you to write it in set notation.
I hate them.
So-
do you go in and look at how we answer?
Sometimes if it's like, if I get an average report of being really low, I go and see why it was really low.
Yeah, because sometimes I'll just be typing it up and I'll just like miss a comma.
Yeah.
And it was kind of wrong. I'm like, come on, bro.
Well, then fix it.
That really annoys me, like, but it's annoying.
Sometimes-
I got this one class, psychology.
It's like,
So few words in it, and like I'll spell like a little tiny bit wrong, and I'll get the entire. So frustrating.
it'd be like partial credit. I'd be like, no, I got the right answer. I'm just missing a comma between the two answers.
Gotcha. All right, so if x can equal 1, that means your domain, you are any number between -infinity and 1, or any number between 1 and infinity. You just can't use 1. Who says I'm having a basketball? Who says I'm throwing a basketball competition? All right, Okay. Yeah. so when we come in tomorrow, I'm gonna have you practicing using the ones we created, and you're just gonna practice evaluating. Is that cool? Okay. Yes.